Y'all can talk like it's fine.
All right, guys, so today we are going to talk about currents and why currents exist, why hurricanes exist. Actually, this chapter we're going to get into hurricanes. We're going to get into like rip currents, how islands are formed, like barrier islands and stuff, how people die in rip currents, what tides are. Coral reefs is the last chapter. We are going to get there. So we're finally getting into actually the marine world, the ocean world. So today we are going to talk about currents. So waves, currents, and tides all move and mix ocean water. Waves, currents, and tides move, mix ocean waters. The most intense motion occurs at the surface. Think about it. If you're carrying a pot of water in your house from the sink to the stove, does the water at the top of the pot slosh out or the water at the bottom of the pot slosh out? Same thing happens in the world. However, the main kind of thing you need to get from this unit is everything is driven by the sun. So the sun is what drives the wind. The wind is what drives the surface currents. So waves and currents are driven by wind. Wind is driven by heat. Heat comes to us from the sun. So the sun is essentially responsible for all of the motion in the ocean. Without the sun, none of this motion would exist. The moon has an effect on tides.
Why tide?
I never understood that.
Yeah,
That didn't make any sense to me.
I'm going to explain it this week. And I have beach balls. I'll have y'all come hold, someone will be the sun and someone will be the moon, and someone will be earth, and we're going to act it out. I promise it'll make sense.
You know how whenever you're on the beach during the day, the waves, whenever they hit the shore, they're not that big, but during night, is that how that kind of works?
It sure is.
That makes sense.
Yeah.
I'd be falling over it.
Yeah, no, definitely. Yeah, and that it has a lot to do with tide. It has a lot to do with the tide action. So we're going to start with the most basic. We're going to start little and get big in this chapter, okay? So the first thing we need to know is the Coriolis effect. There's a bunch of scientific definitions I could give you for the Coriolis effect, but we're going to make this real easy. It's when something that you think should go in a straight line doesn't go in a straight line and it curves. It's when you throw a ball, eventually that ball is going to turn. It's not going to keep going in a straight line forever and ever. You can see it better demonstrated. Any of you ever rode in one of those gravitrons or something where it pushes you up against the wall?
Yeah.
And you try and throw something to a friend or pass something to a friend and it doesn't go to your friend, it hits the person next to you in the face? Or somebody, this sounds disgusting, but somebody throws up on one of those or something and it should go front but it hits that is the Coriolis effect. Right there. That's the Coriolis effect. Yeah.
I pulled for one of those things one time.
It was
But here's the thing though, it didn't hit my friend next to me. It basically just and then it hit back to my face.
I remember there was a ride on one of those or something, and I
And my
was
mouth
move
was
my
open.
arm and I couldn't. All I could do was move my head.
Yes. Centrifugal
I'm
force.
sorry.
It was fun though.
No, I
No one
can't.
threw it up. No one threw it up, so
That's good. Yeah, I can't do it.
Hey, do you know what
All right,
about phone
so,
cake?
huh?
I'm sorry. I was trying. Never mind. It's like you know about phone cake. So I remember that day I ate a lot of phone cake because I love funnel cake. It is so good.
I don't know anything about funnel cake. I never had one until I was an adult.
Wait, what? You didn't experience the goodness of phone cake?
I had a crunchy parent, okay? My mom was crunchy.
Well,
No TV. Definitely no carnival rides.
I didn't know what you meant by crunchy. I was huh?
Yeah, my mom wasn't a hippie, but she believed TV rotted your brain. It does. TV and all that rots your brain. And so she was very holistic. So I ate a very holistic diet. I ate a very,
Yeah, but
Yeah.
funnel cake, it's so good.
So, the Coriolis effect explained. It takes the Earth 24 hours to make a circle. We all know that, right?
Yeah.
24 hours to spin in a whole circle. Thank goodness you learned something in elementary. Okay. At the North Pole, it takes 24 hours to travel in a 6-foot circle. It only travels 6 feet. Y'all, like it's going at 10 millionths, maybe 5 billionths miles per hour. I'm walking faster than the Earth turns to the North Pole. Like me pacing in front of the room, walking around is faster than it travels to the North Pole. At the equator, though, it takes 24 hours to travel 25,000 feet. So at the equator, the Earth is spinning at 1,000 miles an hour. So think about the Coriolis effect like this. If you were standing at the North Pole and you threw a ball towards the equator, you're not moving here. It's going 1,000 miles an hour at the equator. Would the ball go straight down to the equator?
No.
Or would the wind and all of that, the movement, pick the ball up and make it travel to the side? And kind of pull it with it, right?
Yep.
Would make that curved arch. That's the Coriolis effect. That's the Coriolis effect in a nutshell.
Is that like when you get like a beach ball or something, it goes to the side sometimes?
Yes.
What if I have a boomerang?
A boomerang.
Same thing?
Boomerang is shaped. The shape of the boomerang is what makes it come back.
Oh, really?
So the Coriolis effect doesn't come back completely. This shows you what's going on. It's kind of hard to imagine, but this is the pole. It's going slower. If you look at this animation, it's hard to see. If you look at the railroad tracks, this one's going slower. These two are going super fast. So we kick the ball or throw the ball straight towards the goal. But because these are going so much faster, it gets swept up and it travels backwards and it goes in an arched pattern and it doesn't hit the goal. It hits further back than the goal. They're going faster. They're going at a faster speed. So let's talk about how this affects direction. If you are north of the equator, it says hurricanes go in a counterclockwise direction. Everything goes in a counterclockwise direction north of the equator. Go home, flush a toilet. It's going to spin counterclockwise. It's going to spin counterclockwise. It's going to spin like this. However, if you go to the southern hemisphere, it spins clockwise. This is 100% true. First thing that happened when my cousins moved to New Zealand, first thing I wanted to know was I wanted them to send me a video of them flushing the toilet. I really wanted to know if it spun in an opposite direction.
Does it?
It does. It goes the opposite direction if you get south of the equator. So, north of the equator, if you flush your toilet at home, the water will spin left and it'll go down the drain.
Yep.
If you go to Australia, New Zealand, anywhere south of the equator, most of South America, most of Africa, it's going to go right and go down the drain.
So weird.
All of the spirals in your house, so like water draining down a sink, anything like that, it'll all go counterclockwise.
You got like a
Because of the way the Earth is spinning in space.
You got like a video of that?
A video of that?
Yeah.
We can look up a video of that, I'm sure. Let me finish this and we'll.
Where does this one go?
You just have to write the words counterclockwise and clockwise.
And go like YouTube faces.
Any teachers needing a DOT physical, you can come to the gym right now.
Does anyone need a
Any
physical?
teachers needing a DOT physical, you may come to the gym right
Anyone
now.
need a physical for anything?
I'm going to money. So
I think for most sports you've already had to have your physicals, like
Yeah. This was just for people that like
makeup.
put together, I guess.
I guess if they play a spring sport, maybe. Alright. So let's talk about how all this builds. It's one of those slippery slopes. So the wind is driven by heat from the sun. The wind is driven by heat from the sun. Where is it the hottest on the globe? Is it hotter at the poles or is it hotter at the equator?
equator.
The equator. Awesome. What happens when you get gases hot? What does heat do? Does heat rise or heat sink? Heat rises. Is the second floor of your house always hotter than the first floor? Yeah. Heat rises. So the energy from the sun heats up the globe at the equator. The heat at the equator rises. As that heat starts to rise, it pulls in more air behind it. So the heat is rising and it's pulling in air behind it. But we have to remember the Coriolis effect. Is the Earth sitting still?
No.
No. The Earth is spinning at 1,000 miles an hour roughly at the equator. So the Earth is spinning, it's pulling in those winds, so it's making those winds come in at a 45-degree angle.
Oh,
So when the wind gets sucked in to replace it, it gets sucked in at a 45-degree angle. So the ones closest to the equator on the north and south side are called the trade winds. The way I remember that is in history class. Hopefully at some point you've heard your history teacher talk about the trade winds or the trade currents. Christopher Columbus, Marco Polo, Pierre LeMoyne d'Iberville, Hernando de Soto, they all took the trade winds to get across the oceans. Also, I think about the colonies used to do a lot of their trading with Africa and with the East Indies and South America. So the areas where we traded are the areas that the trade winds occur in. And that's all I got. I know that's weird, but that's what goes through my head. North and south of the trade winds, we have the westerlies. Because the globe isn't a perfect cylinder. It's a globe. It's rounded, right? So physics does take over. These westerlies go in the opposite direction of the north and south trade winds. I don't know why we call them westerlies because they don't go west. They go east.
Wait, I got a question.
But we call them westerlies.
What if the two opposing winds was to meet in one spot?
They do. It's called the Bermuda Triangle.
Wait, that's real?
Yes.
This is not.
I thought someone already asked that.
Wait, so like, is that the reason why everything goes missing there?
There's lots of reasons why everything goes missing there, but that's so again, the heat drives the wind drives the currents. So the sun is essentially what makes the Bermuda Triangle as deadly as it is.
So no alien stuff?
No alien stuff, no. There are actual like scientific definitions for 99% of the stuff that occurs in the Bermuda Triangle.
What was the 1%?
We're working on it. It was only like 75% hundreds of years ago. It's probably like 10%, so we're getting better. All right. The polars. The polars are called easterlies. These do actually go to the east. The problem is the polar winds aren't exactly predictable because, again, the Coriolis effect. This is moving at 1,000 miles an hour. These winds are always going to blow in this direction, right? Not even 1 mile an hour movement up here. Do you think those winds could probably overcome the movement of the earth and travel in directions they shouldn't?
Yeah.
Yes, and it does happen. So really your easterlies are pretty unpredictable. A lot of your first expeditions into the Arctic and Antarctic ended up very badly because the winds and the weather there are so unpredictable. The first missions, they expected the weather patterns and everything to be as predictable as they are where we live. That was not the case. And a lot of them got trapped. A lot of them tried to survive the winter off what they had and couldn't. Some really sad stories.
They forced it out?
Hmm?
They forced it out?
Did they what?
Freeze to death.
Froze to death, starved to death. Yeah, you name it. I mean, they were in the Arctic and Antarctic, like, yeah. We actually have y'all know we have a base in Antarctica, right? That people live at?
Do people do live there?
Yes, people do live there. One of the guys I went to high school with lives there.
Is it
He
nice?
lives there 6 months out of the year.
Is it nice?
I mean, it's like a military base, so I mean, they can't go out. They do go outside, but they have to obviously wear special clothing and protection. They travel, and it's really, I think the flight time, it's from Australia to Antarctica, or from South America to Antarctica, isn't that far at all. It's less than an hour flight. So, they fly down there from either South America or Australia. There's a window of about 2 months, twice a year, where they can make that journey, make that trek, switch off, get supplies, all that stuff. I mean, it's like I'll find pictures. I mean, it's not bad. It's not like the Taj Mahal. It's not bad. He studies some kind of bacteria. I don't know. He's got his doctorate and he works at Berkeley. I should have been his friend in high school, apparently. All right. So, the major currents of the open ocean are wind-driven. So we just talked about the wind. We said the wind occurs at a 45-degree angle to the equator, right? All right, so the wind occurs at a 45-degree angle to the equator. But if you're pulling something behind you and you're kind of going in a circle, does it follow you directly or does it kind of follow you at another angle? At another So the wind occurs or the current occurs at a 45-degree angle to the wind. Basically, if all the angles confuse you, know that the currents travel parallel to the equator. The currents travel parallel to the equator. So this, don't judge my drawing. I'm eyeballing it. That's the equator, roughly. That is roughly the equator. So the wind comes in. It moves the water, and the water is going to move. Remember, we've got this Coriolis effect that's pulling us along. So that water is going to move at that 45-degree angle, or at that parallel, another 45 degrees to this 45 degrees. 90 degrees total from the point of input to the point of exit, but again. The wind-driven surface currents occur in these big circles, and we call them gyres. They're really easy to remember. There's two major oceans, right? The Pacific and the Atlantic. So we divided them up. There's one gyre North Pacific and one gyre in the South Pacific because they rotate different directions, right? These rotate different directions. There's one in the North Atlantic and one in the South Atlantic, and then there's one in the Indian Ocean. The Indian Ocean is kind of blocked there. Why do you think there's not one in Antarctica?
Too cold?
The water moves there, but are the winds there predictable?
No.
No. So if the winds aren't predictable, would the water pattern be predictable?
No.
No. We're going to talk in just a second. There's something else that makes the currents there predictable. Oh. All right. So, surface currents continue. So, we just said that the water travels parallel to the equator. You think it's warm water by the equator or cold water?
Warm.
Warm water, right? The water by the equator is warm. The water by the equator is warm. So, the water is going to come along. It's going to be moved by, and I'm going to move in just a second so you can copy. The water's going to come along here. It's traveling by these winds. It hits land, it starts to travel north. But which way do the winds, if these are the trade winds, they're going this way. Our westerlies are going this way. So your current comes in, it's traveling along with these trade winds. It gets picked up, it gets pushed by the westerly, and then it gets pushed north. And it's going to be pushed north. So, warm water currents on the west carry warm water north. Cold water currents on the east carry cold water south. This is what regulates our climates. This is also what leads to El Nino and La Nina. So this movement right here is what regulates our climates. It's what keeps warm air and warm traveling up to the United States of America. You've got your cold waters coming down over here in Europe. You've got your freezing cold waters over here in California. It actually does not get as hot in California as it does over here in the United States. A lot of that has to do with the ocean temperature. You can memorize east and west, y'all. The way I remember this is it hot or cold at the equator?
Hot.
Hot. You think the water coming away from the equator is going to be warm or cold? Warm. If you're at the North Pole, you think it's hot or cold?
Cold.
Water coming from the North Pole is going to be hot or cold? Cold. So I just look at what direction the water's going in. To this day, I just look at what direction the water's going in. If it's coming from the equator, it's warm water. If it's coming from one of the poles, it's cold water. Easier in my mind, my mind, that just makes sense.
So is Antarctica bigger than the Arctic Circle and stuff?
Yes. Antarctica is a continent. It's huge.
With the ice or without the ice?
I'd have to look that up.
Because I
All right.
heard somewhere that Antarctica used to be like a tropical place or something like that.
Next chapter.
Oh. Oh.
Next chapter.
Oh.
Ekman spirals. I could go on and on and on and on and on about Ekman spirals, but I'm just going to show you a video and it should clear everything out. Basically, slowly moves to the right or left and creates a spiral effect as you go deeper and deeper in the ocean. So the wind blows it one direction, and it slowly pulls less and less and less water along with it, and it creates a spiral as you go deeper into the ocean. How many of you have ever seen where you take like a glass and you put it on the napkins and you twirl them around in a circle?
What?
I'll show you the video in just a second. That is an Ekman spiral. That's all it is. That's an Ekman spiral. When y'all are done writing, I'll get out and show you the video.
I'm done.
That's the list of tropical cyclones.
Ah. I just had the meanest nigga fault. Napkin. That's Bible.
What's sad is I had it last block and I'm not going to be able to find it this block. Here we go.
Create a fantastic beverage napkin display using this simple trick from Hoffmaster. First, pick your favorite Hoffmaster decorator colors. Alternate the colors for an added effect. Then, take an empty glass on its side and place on top of the napkin stack. Slowly rotate the glass with steady pressure until the napkins are fanned halfway out. Then, carefully flip the stack over and repeat, going the same direction.
And you get an Ekman spiral. The same thing happens in the water. Because there's more surface friction as you get further and further down, they don't move as far. So the one on the top moves the most, and they move less and less and less as you get further down the stack. So as you get further down in the water column, the water moves less and less and less, and it creates this nice pretty spiral effect.
Is that why whirlpools exist?
Is that where what?
Is that why whirlpools exist?
Whirlpool? Whirlpools? Whirlpools? No.
No. Why did it exist?
I'd have to research it, but I think it has to do with like the ocean floor. 99% sure it has to do with the ocean floor. All right, so upwelling. This is much more common. This is what you can feel upwelling and downwelling. Ekman spirals is going on, but it's not something that majorly drives any one surface current or any one motion in the ocean. So upwelling is the process in which cold water rises to the surface. So just like warm air moves to the top and cold air comes and replaces it, the wind is moving that warm water. So as the warm water gets pushed away, the cold water rises from the bottom and comes up and takes its place. This process is known as upwelling. The reverse can happen. It's called downwelling. It usually happens on a coastline if it's downwelling. So that's where the cold or the warm water sinks and the cold water comes in from the surface to replace it. It usually occurs along coastlines because on coastlines you're going to have the most buildup of matter and particulates in the water. It's going to be denser, so it's going to sink. Upwelling is a really good thing. This is how fish from the deep ocean actually get up to the top of the ocean. So the bottom of the ocean doesn't have much food. There's not much there. And we've actually discovered that a lot of the fish from the bottom of the ocean, just like they do in Finding Nemo, they ride around East Australia. But the fish in the bottom of the ocean actually ride up on these upwellings. So they ride up, they use this pressure difference to push themselves up in the water. The water moves them up, they're able to eat and feed. Then they're gonna ride a downwelling back down to the bottom of the ocean. So they didn't put forth any extra effort or energy. They're riding what's already taking place in the ocean. Also, not much is going to live or occur in that top 2 or 3 feet of water. Your most fertile areas of water are about 3 or 4 feet beneath the surface of the water. So when upwelling happens, it's bringing that nutrient-rich water to the surface. It's where, like, if you were going fishing or anything, you want to find an upwelling. Another, and I say if you're going fishing or anything, y'all, we figured out that a lot of your big ocean fish, great white sharks, tunas, all that stuff, they hang out by where these upwellings are, and they just wait. Because they know as the water column rises, it's going to bring fish and stuff up from the bottom, and they have a free buffet now. Works for them. This is a picture. It kind of helps a little bit. So here's the warmer surface water. It's moving. This cold water is coming up, replacing it. It's filled with phytoplankton, zooplankton, fish. And it's coming up, it's replacing this water up here, so it's pulling all of these nutrients and life up to the surface. If you've ever been at the beach and you're walking along the beach and the water's all the same temperature, then all of a sudden you get to the spot and you're freezing and the water is ice cold. Y'all, it's happened to y'all, right?
Yeah.
Somebody, anybody?
Yeah.
No? You've hit an upwelling. That's what you've hit. You've hit an upwelling. Look around you in the water right there. You'll probably see more, if you see any fish life or anything, it's going to be more active right there than it would be anywhere else.
I remember I used to go to Octobuck Lake. They're like this huge dam place. Like this huge dam, and like a little bit away from the dam, there's like just like beachy area that me and my family used to go to, like called like Octobuck or something like that. I don't know if I remember that correctly. But like this huge lake area, and then we used to always go there. I used to always like to build the sand castles. But every time you used to like to walk in there, there used to be like tons of fish and stuff.
Mm-hmm.
But like this one time, this dude was like his like jet ski right across the water, and he's like a huge wave. It went towards just like thrown into the water.
Yep. But none of this happens in a lake because this is all ocean driven. So we're out in oceans. We're out of, for the rest of until we get to ecosystems, we're not talking anymore about lakes, rivers. We're in saltwater only.
Yeah.
We're leaving freshwater behind. We're in saltwater. So before I tell you what these are, what does the word thermo mean?
Temperature?
Temperature. Haline sounds like saline. What does saline mean?
Oh, salt?
Salt. So these are currents that are driven by temperature and salt. They're driven by temperature and salt. So these are deep ocean currents driven by differences in water's density. This is what happens at the polar regions. So you know how I said the polar regions, their winds weren't predictable there? This is what's going to drive currents at the polar regions. So what happens is the water, as it gets colder and colder, it starts to freeze. Remember, it has to be colder for salt water to freeze. Also remember that the only way to change the salinity of the water is to add or take away water. You can't like pour more salt in the ocean and make it more salty. When water freezes though, it leaves the salt behind. It doesn't freeze with the salt in it. The salt comes out of it. So there's a ton of salt right here. This water is saltier than this. This is greater than 35%. So because it's saltier, it weighs more, it's going to start to sink. It's more dense. This fresher water is going to come fill in this space. But it's below 0 degrees Celsius, so it's going to keep freezing. As it freezes, it leaves the salt behind. This water becomes more dense, it sinks, the fresh water comes in and it takes its place. It makes this circular motion that goes deep down in the ocean. This is what drives the current at your poles. So the heat heats up the equator. You've got your warm water that is picked up by the trade winds. Then it gets picked up by your westerlies. As it starts to travel north, it gets influenced by these thermohalines. These thermohalines push it back south. That cold water slowly moves back towards the equator. It's hot at the equator, right? That water heats back up, and it repeats the cycle over and over and over again. Scientists think it takes thousands of years for one gyre to complete its cycle. So it takes thousands of years for water to get from the equator to the pole and back. So don't expect like to throw something in the equator and have it come back to you the same day in the water. Like, not happening.
Okay, I got a question. How did glaciers, you know, call it the glaciers of the Titanic, like, how did it get from the Arctic Circle to down there where the Titanic is without melting from all these hot ocean temperatures from the
The
equator?
Titanic wasn't that far from the Arctic Circle.
Oh. Well,
Let's look at a map.
really? I mean, I thought like they said like it was like in the Atlantic or something.
It was.
So which part?
The Titanic was coming from here
Oh, that came from America.
to here. Y'all think, and it's so funny, when you think about traveling across the ocean, you think like you're traveling straight, like you think like England is like straight across the ocean. Y'all, it's way north of us.
Is Greenland really that big?
Yes, Greenland's really that big. So the Titanic was out here when it sunk. Greenland is a bunch of ice, right?
It is? Oh yeah.
Yeah, Greenland's ice, Iceland's green.
Well,
That makes no sense. Like I know the differences, but like why do they name it Iceland if it's
My teachers used to always say that when the Nordics named it, they did it to confuse people. So they named Iceland Iceland and kept the good land for themselves, and tricked everyone to go into Greenland. I don't know if that's true or not. That's what my teachers used to say when I was in high school.
That's what they told me too.
Is that what they told you too? Okay, I'm glad like that myth has still stuck around.
Is Greenland a part of Europe or is it a part of North America?
It's its own island. It's its own country.
so who's it?
It's a big island.
It's considered part of North America. Sometimes it's also considered part of the Arctic.
Okay.
It's big ice sheet, pretty much. It's a massive ice sheet, kind of like Antarctica.
So people live there? Do people live there?
Mhm.
Like a lot or like a little bit?
Yeah, people live in like Nova Scotia and crazy places in Canada. People live in Alaska.
Oh my god.
I mean, if you think about it too, like where the Titanic was south of where Alaska was. So
I forget how big Alaska is.
I forget how. Yes, that's one of the. Yeah.
It's like.
I'll admit the first thing I'm guilty of is forgetting how far north Europe is compared to the United States. Like,
Yeah.
I always think like all of this is below the equator. I'm like, oh yeah, like the equator hits like Italy, Spain. Like, no, it's like down here, honey. It's just my mental. It's weird to see, especially we won't do it this time in this class. We usually like cut all the continents out and like put them on a piece of paper, and it's weird to see Antarctica not drawn like a straight line, like it's a round continent, like it's a circle. Antarctica is a circle. It's not. It's like it looks like Australia, like it's a circle of land, and it's just weird because we always see it drawn like
Wait, so
that.
Antarctica is like round and
Mhm.
is it the biggest continent?
I don't know.
I wonder what's inside the frozen water of Antarctica. Well, we know we call it like a giant monster.
That's what Bradley does. He works on bacteria, but that's what the researchers are down there looking at. They're trying to find out what. Now that we have the capability and the technology for people to live there and sustain life there, we're trying to figure out exactly what is there. All right. So I had a video for El Nino and La Nina. I won't make you watch it. Let me just tell you this. El Nino means little boy or Christ child. El Nino was first not discovered, but the research was finished and completed and all that around December time, during which these warm water events tended to occur. So because it happens around December every year, they named it the little boy or the Christ child. Hopefully y'all know enough Spanish to know El Nino means boy, right?
No.
El Nino means boy. El Nino means boy in Spanish.
Oh.
So it happens in winter. El Nino happens in winter. It brings warmer than average temperatures and wetter than average conditions. So what's going on is, don't judge my drawing. We've got like California, and then we go into like this Mexico area, and then we have the Panama Canal or whatever, and then we have South America, right?
Yep.
Again, don't judge my ability to draw. It's a little less T-bone shaped. Okay, so I talked about upwelling upwelling and downwelling, right? So in upwelling, the warm water is pushed to the side and the cold water comes to the surface, and it's driven by those trade winds. So what's going on is the warm water is being driven this way because of the trade winds. It's heading towards Asia. The cold water is coming up and taking its place in the wintertime. What happens during El Nino is the trade winds are really weak. So instead of this upwelling moving, this upwelling hangs out right here. It doesn't move away. It doesn't go somewhere else. So the warm water stays close to the shore, so it brings warm, wet conditions. El Nino brings warm, wet conditions to our area of the United States. The way I remember it is if you think about a little boy playing on a playground, he gets hot and sweaty, right?
Yeah.
El Nino means little boy. It brings hot, wet conditions just like a little boy playing on a playground. He's hot and wet and nasty when he gets done.
I mean, nasty. You know, yeah, definitely nasty. Yeah, I'm not that white, that bottom way of white.
You don't have to write all the red.
Oh,
What kind of conditions does it bring? Warm and wet. When does it happen? The winter. And the way I worded it on your test, I think it asks it says during December of something, the average temperature was up 10 degrees and the rainfall was above record normals. Were they experiencing El Nino, La Nina, a hurricane? La Nina. If El Nino means little boy, La Nina means little girl. It simply means it's cold outside. La Nina also happens in the winter. What's going on with La Nina is El Nino, those winds weren't blowing strong enough, and that warm water sat right here. Well, when those trade winds finally get going, they blow a little too strong. All the warm water comes over here to China, and this area of cold water gets massive, and it gets bigger than it should.
so it's cold.
So we have a bigger than we should area of cold water sitting right there.
So what time of year?
Winter. And it's opposite of El Nino. So if El Nino brought hot, wet conditions, what do you think La Nina does?
Cold, fire conditions?
Cold and dry. Cold and dry to our area of the United States. Now, it's going to affect every area of the United States differently because the water masses are affecting the temperature of the air, and it's affecting that jet stream, and it's how the jet stream moves is how our weather is determined. But we're only in water class, we're only in marine class, so we're only talking about one part of it. So we're just going to learn about what happens to our area of the United States, because I don't want to have to teach y'all about how the jet stream moves and all that good stuff in the all the layers of the atmosphere. That's Earth and science. That's Mr. Holland's territory. And these are just fun things to think about. It says, just for fun of it, someone walking along the shore in Beaufort, South Carolina, there's a message in a bottle in the sea. The bottle ends up on the west coast of Australia. How did it get there? So,
Wait, what?